Perfect. So I think it's a good time to start. Welcome, everyone, to today's ScHARe webinar on data management and analysis in Python. So we are excited to have you as we dive into the powerful world of Python for managing, analyzing, and visualizing data. So this session is designed to be both informative and practical. So it caters to participants who want to get hands-on experience while learning the essential tools and techniques for handling data. And whether you are a beginner looking, to sharpen your skills or, gain new skills, or an experienced programmer or data scientist seeking to refine your data analysis workflows or abilities, this webinar should have something for everyone. So this webinar is part of the ScHARe series. ScHARe stands for Science Collaborative for Health Disparities and Artificial Intelligence Bias Reduction. I'm going to tell you in a moment what ScHARe is for those of you who joined us today for the first time. Today, we'll be covering key topics such as the importance of data cleaning, the tools that you have available on ScHARe and elsewhere for data cleaning, how data impacts visualizations, something about an introduction to machine learning, and some practical examples of data visualizations, data cleaning, and machine learning. So our goal today is really to provide you with both the theoretical foundation and also some practical experience, to make you more confident in managing and analyzing data using Python. So there will be hands-on exercises throughout. So we're going to explain in a minute how that works. But first, I'd like to start with our experience poll. We do this every time. We're going to ask you to indicate your level of experience with Python, R, cloud computing, Terra, and health disparities or health outcomes research, and algorithmic bias mitigation. And I would ask Kevin to please take over and explain how Slido works. Slido is the platform that we use for all our polls. So Kevin, thank you. It's all yours.
Great, thank you, Luca. So as Dr. Calzoni mentioned, today we'll be using Slido throughout the webinar to get some feedback from you, the participants. To use Slido, you can either download the Slido app on your phone or simply go to slido.com on either your phone or your computer. Alternatively, you can scan the QR code that you see here on the screen on your mobile device, and that will also bring up the Slido. Lastly, my colleague Mark will be putting the link for Slido in the chat now. So you can also click the link that's being put in the chat to access the Slido. To join Slido via slido.com or the app, you can just enter the code Python where it prompts you to enter code here. For those of you on slido.com, that will be at the top of the page in a blue box like the one you see here on the slide. And when we get to time for Slido, which we're about to launch into, the code will also be displayed on the screen. So you'll have a few seconds here once I move on from this slide. So just very quickly, I will go ahead and we will switch over to our first Slido poll. And so once you pull up Slido, again, Mark has put the link in the chat. You can use the QR code here, or you can use the code Python on slido.com. Please go ahead, fill in this experience poll, and then we'll take a look at the results once we have a certain number of responses.
Thank you, Kevin. Yes, we do this to also track, evolution over time, our audience, and to also tailor our future events, better depending on the kind of audience that we reach and their skills. So it's really important that you participate into this. Thank you. And Kevin, whenever you're ready, we can display the results. Okay, perfect. So, well, this is what we want, right? So many of you, 62%, have no experience with Python, which is perfectly okay. And most of you have some experience with R, 43%. So our platform ScHARe supports R and Python. So your experience with cloud computing, none. That's Fine, that's expected. That's why we are holding these events and webinars to teach you how to use that. And same with Terra, perfect. Terra is the platform that powers ScHARe. I'm going to tell you about that in a minute. And okay, half of you have some experience with health disparities research. Well, 32% of you is proficient. And in terms of health outcomes research, almost half of you have some experience with that. Perfect. And bias mitigation, perfect. Almost 80% of you have no experience with that. Great. We're not going to focus on that today, but it's good to know because we are launching another series of AI bias mitigation soon. So perfect. And then
now we're here. Now we're here in our second poll. So please feel free to take a second. It will pull up right on that same page on Slido that you were at. So please take a few moments and respond to this interest poll. Thank you.
So with this poll, we are asking you what you're interested in. So how do you envision using ScHARe, or why you're attending today? What are your goals? And again, this is going to inform you the development of new initiatives and the next webinars. And again, here, Kevin, when you're ready. Okay, perfect. So most of you are here to learn how to use AI tools and cloud computing, or to gain new skills for research, leveraging big data. And some of you also plan to use those skills for health disparities in health outcomes research, I see. Perfect. 60% of you are interested in developing bias mitigation and ethical AI strategies, which is great. That's an upcoming part of our series. Great. Thank you, Kevin. I think we're good, and we can keep the poll open so that people can finish responding. So I'm going to share my screen again. Okay, perfect. So what is ScHARe? Let's start with that for those of you who are new to the series of webinars. So ScHARe is a cloud-based platform. It's a population science data platform. It's designed to accelerate research in health disparities, health and healthcare delivery outcomes, and AI bias mitigation strategies. We have 4 main goals. We want to increase participation of women and underrepresented populations with health disparities in data science. We want to leverage population science, social determinants of health, and behavioral big data and cloud computing tools to foster this paradigm shift in health disparities research. So we want people to start thinking about a new kind of research questions, more innovative and leveraging all the new tools and resources nowadays available. The third goal of ScHARe is to advance AI bias mitigation and ethical inquiry by developing these strategies to reduce and mitigate bias in AI tools and in data sets. And finally, the fourth goal is to provide a data science cloud computing resource for community colleges, low-resource minority-serving institutions and organizations, and for underrepresented researchers in data science. ScHARe is powered by Terra. So Terra is basically an interface to Google Cloud Platform. It offers secure workspaces, data storage, computational resources, and on our workspace, you will also be able to find tutorials, code that you can easily reuse, both for Python and R, to analyze, visualize, and plot data. And most importantly, learning how to use Terra on ScHARe is also going to prepare you to use other NIH platforms that use the same engine. the same platform. So as you can see on the right, once you learn how to use Terra, you will be able to also use all of Us platform and the Biodata Catalyst and a series of platforms that will enable the mapping of across cloud platforms. So that's a really interesting possibility. And in terms of components, ScHARe co-localizes within the cloud datasets, including social determinants of health and social science data that are relevant to minority health, health disparities, and healthcare outcomes research. A second important component, which is going to be launched soon, I will tell you about that in a minute, is the CDE-focused data repository that we just developed. And that repository allows to comply with the required hosting and sharing of data from NIMHD and NINR, which is our partner institute, funded programs. And then a third component are these user-friendly computational capabilities and these secure collaborative workspaces that we offer for all career-level researchers and students. I'm going to tell you about that in a moment. And finally, the fourth part, which is upcoming, as I was mentioning, we're going to offer tools for collaboratively evaluating and mitigating biases associated with data sets and algorithms utilized to inform healthcare and policy decisions. So you can see on the right, a representation of all these components and how they are integrated into ScHARe. This is what our interface looks like. We're going to use it today. And ScHARe offers secure workspaces to all researchers. They can work in these workspaces independently, or they can collaborate with their colleagues. And users are able to assign roles. So you can decide whether your collaborators are going to be able to see, edit your data and notebooks, if they can be administrators or just viewers. And of course, you're able to host your own data and code on the platform. Another section of the platform is devoted to analysis. So there are a series of notebooks that can be used for analytics and provide instructions, really simple step-by-step instructions on how to access, visualize, analyze the data sets that are available on ScHARe, and also how to import data from elsewhere. And we try to really make this as simple as possible. So that's the goal of those tutorials with step-by-step instructions. We use modular codes, meaning that we provide examples on how to access, for example, data, and these instructions can be easily followed, and the code that we use can easily be copied and pasted and reused, to accomplish the same tasks elsewhere. And we are also adding, for those users who are less familiar with R and Python, SAS to the platform. So the statistical packages SAS, to facilitate a little bit things for people who are not used to R and Python yet. And what data is available on the platform? So I'm going to show you the workspace later, but from the analysis tab, we have one notebook that lists all the data sets available on ScHARe. And in the data tab, we have data tables that help you access the data. So what kind of data is available? Well, researchers on ScHARe can access, link, analyze, and export a wealth of SDOH and population science-related data sets. And as you can see, we have both public data sets, about 250 federated public data sets, which are publicly accessible, federated de-identified data sets that are hosted by either ScHARe or Google through the Google Cloud Public Dataset Program. And you can see some examples listed here. So, for example, the Behavioral Risk Factor Surveillance System or the American Community Survey. So they are pretty frequently used data sets, and it's helpful. And then in the CDE-focused repository, we're going to host publicly accessible and controlled access funded program and project data sets that use common data elements shared by NIH grantees and intramural investigators to comply with the NIH data sharing policy. And you can see some examples there of such projects. And we use this innovative approach. We enforce the use of common data elements. I'm going to talk about common data elements in a moment to show you what they are and why it's important to use them. So here you can see the ScHARe ecosystem and the data that I was mentioning before. This is a screenshot from the data section. And you can see that we have categories of data that reflect the social determinants of health categories by the CDC. So those categories are economic stability, education access and quality, healthcare access and quality, neighborhood and built environment, social and community context. And we added two, actually, so health behaviors and diseases and conditions. And from the data tab, you can actually visualize all these categories, explore the data sets that are available, and on the right, access the actual data and import it into your workspace or download it on your computer. So these are the categories that I was mentioning before, right? So for those of you who are not familiar with the social determinants of health, they are the non-medical factors that influence health outcomes. So the conditions in which people are born, grow, work, live, and age, and the wider set of forces and systems shaping the conditions of daily life. And you can see some examples of the kind of data that we offer here. So for example, for education access and quality, we have data on graduation rates, school proficiency, interventions to address developmental delays. Then we have data on healthcare access and quality, including health literacy or access to health insurance. Data on neighborhood and built environment, so data on pollutants and environmental risks, for example. Data on the social and community context, so crime rates, imprisonment, resilience to stress, or experiences of racism and discrimination. And then data on economic stability, so unemployment, poverty, housing stability, food insecurity. And finally, those two categories that I was mentioning before that we added, they're not social determinants of health, but we do host data on health behaviors, so health-related practices that can affect health outcomes, and diseases and conditions, so incidence and prevalence of specific diseases and health conditions. And you can see here some examples of some of the data sets that we host. These are the ones hosted by Google, and you can recognize some popular data sets there. So the ACS, American Community Survey, for example, or the Area Deprivation Index. And the slides will be distributed, so I won't go over each of them. But this slide provides instructions on how to access Google-hosted datasets. The Google public datasets are available for access on Terra using BigQuery, which is the Google Cloud Storage solution for datasets for structured data. It's really easy to use, and we do provide notebooks explaining step-by-step how to access this category of datasets. And we also make available a PDF list of all the datasets available on ScHARe. So you can actually scan the QR code, or you can copy and paste. Actually, I would ask Kevin to please do that. There is a link to the right, and it points you to this file that you can download to see what kind of data sets are available on ScHARe. This is what I was mentioning before. So the common data elements that are going to power our repository. So for those of you who don't know, a common data element is a standardized, precisely defined way of asking a research question, right? So it's a question paired with a set of allowable responses. And the goal of common data elements is to use them systematically across different sites, studies, or clinical trials to ensure that the data collection process is consistent. And because researchers use CDEs, then they're able to more quickly share data, get results faster. And you can see some of the benefits listed here on the top. So CDEs allow for a faster startup for projects, better data aggregation across projects, and coding actually enables an URI approach, we call it. I'm going to tell you about that in a moment, but for better data interoperability. So our repository, which is going to be launched in October, is going to be focused on common data elements. And I'm going to show you a few screenshots of our repository in a moment. But first, I wanted to give you a quick look at our CDEs, our common data elements. So as you can see, most of them are related to the social determinants of health or demographic data. So we have, age, sex, gender, marital status, education, annual income, household size, English proficiency, etc. And these CDEs were approved and endorsed by NIH, so they are published in the NIH CDE repository, and they are searchable on the repository. So you can actually use the link to the right of the slide to access the repository and search for these data elements. And these are some screenshots of our ScHARe repository, which is going to be launched in October. And you can see that you'll be able to host your project data in a safe space. So with privacy levels, secure workspaces within our collaboration platform. The repository is going to be focused, as I was saying, on common data elements. Our main focus, of course, is going to be social science, social determinants of health, health disparities, and health outcomes research. And it will allow you to also link your data with others, data from other researchers, and also federated data. And I'm going to show you that we will offer tools that will enable you to map across data sets and make sure that the data you upload to the repository is mapped and uses the ScHARe common data elements. And there is going to be an easy-to-use procedure to do that. And you see that for every data set, we are going to display like the number of project CDEs that match or can map to the ScHARe Phoenix CDEs. And this is going to allow you to quickly determine and visualize to what extent two data sets, for example, can be combined based on those common data elements. Because another feature that the ScHARe repository is going to offer is the possibility of aggregating data sets. It's going to be really easy, so with drag and drop features. I'm pretty proud of that. And to view, the aggregated data set, of course, using data views. But that's upcoming in October, so we'll learn more then. We're going to have a Thinkathon dedicated actually to the launch and to explain how to use the repository. And finally, I'm going to mention the Thinkathons because that's our way to upskill underrepresented data scientists and to train underrepresented populations, women, racial and ethnic and sexual gender minorities, rural and poor populations in data science and help them gain those skills. So we want to facilitate this generational career and discipline exchange where data scientists learn from researchers and researchers learn from data scientists, right? So that people with coding skills can teach those skills to researchers and vice versa. We do host events such as the Thinkathons every month. So it's the third Wednesday of every month at 2 p.m. The goal of the Thinkathons is, again, to upskill those underrepresented populations. And we do have two kinds of Thinkathons. The first type is, tutorials and targeted Thinkathons, such as this one. So they are monthly sessions, 2.5 hours in length. They are instructional and interactive. They are designed for both new and experienced users. And the goal is to teach those skills, right? So you can see some of the topics listed here. So data science 101, for example, or how to use Terra, how to use common data elements, how to make data ready for AI. And the second kind of Thinkathons that we host are research Thinkathons. In the research Thinkathons, teams of researchers at various levels of experience and from different fields, they come together and they work around projects focused on the social determinants of health or health disparities research, and they use the tools that we make available on ScHARe for research purposes. And the goal here is to eventually come to a publication and publish the results of their projects. And I would invite you to visualize the upcoming Thinkathons and register using the link that you can see to the right here. And I will actually ask Kevin to please put it in the chat. You'll be able to see what's coming next. And here is an example of some of these are actually a list of all the thinkathons that we held so far. So you can see that some of them, the ones in red, were about skills and how to use the platform, for example. So, well, actually, you can see AI and cloud computing 101 or an introduction to Python for data science. So really teaching those skills. The green ones were about teaching users how to use ScHARe, how to access the data, how to use the notebooks that we make available. And the ones in brown here, we had a series of common data elements, how to aggregate data, prepare it for AI. And so that's also something that is interesting, hopefully. And we also had some targeted thinkathons. So we had one for educators, so community colleges, low-resource MSIs, minority serving institutions. And we had one for American Indian and Alaska Native researchers. We had another one for coders and programmers to try to reach that audience and make that generational exchange possible. So our goal is mainly to teach you how to use those tools and how to conduct ethical AI. So to use those AI tools ethically, promoting transparency and fairness. So promoting, for example, the use of documentation for duplication or reuse, learning tools such as data dictionaries, health sheets, model cards, right? And then promoting fairness. So making sure that the data that you use for your projects is fair. So findable, accessible, interoperable, and reusable. And of course, that data represents relevant population, so it's not biased. One of our goals is also to develop this training and mentoring pipeline where we use AI experts, such as the guest experts that are going to join us today, to train and mentor users in AI and AI tools so that they can also transition later on to other programs, to more advanced programs such as Aim Ahead, for example, where they can reuse the skills that they learned with ScHARe to continue their research projects. And as you can see, as I said before, when you learn how to use Terra on ScHARe, you'll be able to reuse those skills also on other platforms, such as All of Us or Biodata Catalyst, for example. So we are trying to develop really this training and mentoring pipeline. Perfect. Now it's time to set up everything for our workshop. So I'm going to explain how this works. For the purpose of today's webinar, you have been registered for ScHARe, and you have been added to a free temporary billing project that will allow you to run the event materials today with your instructors. Now, you can always opt out if you wish. So you just have to email us at share@mail.nih.gov. And something important that I have to share with you is that you will be active on this billing project for the duration of the Thinkathon, so for today. And if you want to access work in progress after this time, you will need to set up your own billing. There are instructions that we provide on our website, and you'll have to copy your workspaces to it. The notebooks that are going to be used today for the hands-on parts are going to remain available to you. They're going to be uploaded to our ScHARe workspace, and you'll be able to access them and visualize them even after today. Perfect. So let's now make sure that everyone is ready for the hands-on parts. So let's make sure that everyone has provided their Gmail address and has been registered for ScHARe. So we did that. We registered each and every one of you. So the next step that we have to focus on right now is to help you create a Terra account if you haven't done so already. And we need to also make sure that you can access the tutorial that we will be using today. And I'll help you configure your cloud environment and teach you how to run the tutorial. And then I'll leave this to our guest experts so that you can run the tutorials with them. Okay, perfect. So I would invite everyone to please paste the address below in your browser. Kevin, can you please do me a favor? Can you copy and paste it in the chat? So that everyone has it available. I'm going to repeat the instructions twice, and I'm going to give you plenty of time to follow every step. So if you copy and paste that address in your browser, if you have already created a Terra account and are logged in, you would see this screen. But most likely, since we are here to help you create a Terra account, what you will see is this page. So this page invites you to log in to Terra. And all you have to do here is click on the login button at the end of the page. I'm going to repeat the instructions twice, and I'm going to ask you also if you have any questions. So in the next screen, you'll be asked to sign in with Google. You need a Gmail address to use Terra, as we specified in our invitation emails. So please click on the Sign in with Google button, and you'll be brought to a screen where you'll be asked to input your email. The email address that you have to input here is the Gmail address that you provided us with, which has been used to register you for Terra and for access to ScHARe. So please input that Gmail address here and click on Next. In the next screen, enter your password, which is the password associated with that Gmail address. Again, I'm going to repeat everything in a moment. But when you're done entering your password, click on Next. And you should see this screen, which is a new user registration screen. So please input your first name, last name, and a contact email, which can be different from the Gmail address you just used to register. And then click on Register at the end. And it's going to bring you to a screen where you'll have to accept the Terra Terms of Service. So scroll down until the bottom of the page and click on the blue Accept button. And once you do all of this, you just see this welcome page, which says, Welcome to Terra. So now I'm going to stop. I'm going to see if you have any questions in the chat, and I'm going to repeat the instructions again. Elif, also, if you can please help me with the questions. So if someone has questions or needs help. So some of you are saying that you're getting an error saying you cannot access Workspace because either it does not exist or you do not have access to it. So I'm going to help each and every one of you that has that error. We're going to open a breakout room and I'm going to help you. Okay. So let me repeat the instructions real quick. And then we're going to go to the next step. So all of this is in preparation for the hands-on part. Okay. Perfect. So if you copy and paste that address on your browser, in your browser, you're going to be brought to this page, which asks you to log into Terra. So click on the login blue button, this one. In the next screen, click on sign in with Google. When you do that, it brings you to this screen where you have to input the Gmail address you provided us with to log in. So please do that. This is the Gmail address you gave us. And then click on next. In the next screen, enter your password, which is the password associated to that Gmail account, and click on next. It's going to bring you to this screen, a new user registration screen, where you'll have to input your first name, your last name, and any contact email. And then you have to click on register. And then in the next screen, you're going to approve the Terra Terms of Service by scrolling down and clicking on the blue Accept button. And you will see this welcome page. Perfect. So are there any questions or anyone who needs help?
Yeah, thank you for going through all this. I am not getting my register icon lighted after filling all the information for registration.
Mm-hmm.
And so I'm not able to click register, and I plug in everything correctly.
Okay.
Name, email, department, and everything.
Okay. Like the registration button comes up once you accept the terms of service. But let's do this. I'm going to ask Kevin to please set up a breakout room for later. I mean, now we need to do a few more steps. And then I'm going to help each of you, if you're having issues accessing.
Okay, thank you. I got it.
Okay, perfect. I'm glad.
So, Amin, thank you very much.
You're very good. I'm
I'm
going to help you in the breakout room. I mean, any one of you who has issues. Okay. Perfect. And then I would invite you to now copy and paste that address that I was mentioning before. And that should be available in the chat. And you just see a workspace which looks something like this. If you're not able to see it, let me know in the chat. You might get an error saying that Google is syncing permissions for the workspace. This could take like a few minutes. It's normal. And you'll just have to refresh the page, to wait some time and then refresh the page. But I'm going to help you with this if it's not going to go away.
Yeah, I'm sorry. Looks like I'm on a wrong page. It's called Thinkathon.
Mm-hmm.
The same page as I should be.
Okay, let me do this. I'm going to help everyone in the breakout room. It's going to be probably easier to do that.
Yeah, Luca, so if you're ready to go in the breakout room, how we'll do this is we're going to ask everyone who needs assistance, go ahead and raise your hand in the Zoom, press the little raise hand icon, and then that way we will move you into a breakout room with Luca when Luca's ready to assist. So Luca, At this point, are you ready to assist people, or do you want to hold off and cover some other things first?
I'd like to cover like the next steps for everybody who is able to access so that they know where to go and what to do. And then we're going to do the breakout room.
I can go to breakout room, Luca.
I'm sorry, Ali?
I can go to breakout room with participants.
Oh, I'm so sorry. I couldn't hear you. Oh, Alif, can you do that? Can you go to the breakout room? Okay, perfect. Even better. Thank you so much. So Alif is going to help you. And I'm going to show the next steps in the meantime. So Alif, can you do that too? Like explain how to configure the environment once you help them out? Thank you.
Yes.
Perfect. Thank you so much. Great. So once you get here, you have to open the notebook. And you should see a button saying, actually, playground mode. This button here. So you should see two buttons, one saying open and one saying playground mode. If the playground mode button is not available and you only see the open button, just click on that. This happens because we need to configure your cloud environment first. So if you're new to Terra, you likely will only be able to see the open button. And once you click on open, a window like this is displayed. It asks you to configure your virtual machine that you're going to use today for the purpose of the hands-on exercises. So on this window here, don't worry about changing any parameter. Just scroll down, reach the bottom of the window, and click on Create. That's all you have to do. I'm going to repeat these instructions as well, don't worry. Sounds complicated, but it's really not. It's a couple of steps. So we are configuring the virtual machine that you're going to use today.
So it's fine if it says you can navigate away and return in 3 to 5 minutes
It's
after you
perfect.
select that in Terra. Okay,
That's
thank you.
what we want to see.
Okay,
It
perfect.
takes
Thank you.
3 to 5 minutes to configure the cloud environment. So that's perfect. You did everything correctly. You see, here it
I
is.
have an error previewing an analysis message.
Okay. So can you please enter the breakout room? Kevin, can you please move everyone who needs help into the
Yeah,
breakout?
Luca, we're working on sending people, but as you can see from the list, there's quite a few people. So so just raise your hand, have a little bit of patience, and if you need help, we'll move. If you have your hand raised, we'll move you right over to the breakout room right now.
Perfect. Thank you so much. And I'm going to repeat the instructions in the meantime. So the next step will be to click on the playground mode button, which should now be available. And it's going to display a screen explaining what playground mode is. So it allows you to use the notebooks that we prepared without actually modifying anything. So you can run the code, run the computations, but your edits will not be saved. So it's perfect for today. And you have to click on continue. And if all goes well, you will see this screen. You'll click on continue and you'll be done. So I'm going to repeat the instructions again. Okay, so once you get here, after creating a Terra account, paste that address in the chat. And you should see this page. You should have access to the notebook we prepared. There's going to be hopefully 2 buttons there, an open button and a playground mode button. Playground mode is what you want to click on. If it's not available and you only see the open button, click on that. A window is going to open. It's going to ask you to configure your cloud environment, which means your virtual machine. Don't worry about any of the settings here. Just scroll down, go to the bottom of the window, and click on the Create blue button. If all goes well, you should have this creating cloud environment message. So it's going to ask you to wait and return in 3 to 5 minutes. And at that point, you'll be able to click on the playground mode button and then on continue in the next screen. And you'll be done. You might get an error message. That's normal. You just have to try again in a few minutes. I'm going to tell you that because it happens sometimes, especially when multiple people are trying to access at the same time. But it's completely normal. It's something related to the Terra platform and how it works. And it's going to go away in a few minutes. So you just have to refresh the page and retry. Perfect. So if anybody needs help, please raise your hands. You'll be moved to the breakout room. And in the meantime, I try to move on and go to the next section. So why Python? Well, Python is a computer programming language. It is used to manipulate and analyze data and conduct statistical calculations. It is used to create data visualizations, to build machine learning algorithms, and it's based on data science libraries that are really, really powerful. So you can see some examples here and some example applications. So you can find anything from like linear algebra, mathematical functions, handling data structures, and all data science tasks that you can imagine, and also machine learning tasks as well. And it is really powerful. It is one of the alternatives that the ScHARe platform offers. We offer R and Python. You can use both languages in your notebooks, and we are adding SAS, as I was mentioning before. R is a programming language as well. I mean, it's used for statistical computing. It's used by data miners, bioinformaticians, and statisticians. And similarly to what happens with Python, with the data science libraries, our users have also created packages to augment its functions. And a graphical user interface is also available. It's called RStudio, for example, and it's available on ScHARe. So we decided to focus today's tutorials on Python because about 70% of machine learning developers and data scientists actually use Python versus 24% of them using R. It's more powerful, especially when it comes to AI and machine learning. You can learn it really easily. So you can take 2 to 5 months maybe, but you'll be able to write your first short program in minutes. It's really easy to use. And you can also learn it without experience. So it's the perfect programming language for people without any experience. It's easy to understand.
I'm sorry, can you please send me to the breakout because my page isn't refreshing. It's still giving me an error message. So I'm not sure.
Can you paste it?
Yeah, Michelle, you've been sent an invitation to the breakout room. You should see it in your Zoom window. And you have to accept it. Yep.
Sorry about that.
No problem. Perfect. And then at the end of the meeting, if we have time, I will provide you with additional links to free learning resources that you can use to learn Python. And now it's time to get started with the hands-on part. And
Hey, Luca, I have a question.
sure.
Why would I use Python? Why would I need to use Terra in order to use Python? Is it just because it's easier to access the NIH datasets? Is that what it is?
Yes.
Okay,
yes,
that's the only reason why. Okay.
There are many IDEs, we call them. There are many ways to use Python. And of course, Terra is only one of them. The advantage here is that if you're interested in doing health disparities research, as many of you said in our polls, then you have a wealth of data that is available directly in the platform, and it's readily available to you. That's the main advantage. But of course, you can use Python anywhere. You can use it on your computer. You can actually download the data if you're interested in something we offer, and then just conduct the analysis on your computer. So of course, that's always a possibility.
Because you have to pay for Terra, right? I see the rate per hour in the corner.
So You will not pay anything today because it's on us. And when you register, first-time users get $300 in credits from Google directly that they can use towards, analysis and etc. So yes, every computation you run on the platform is going to incur a small cost. And you saw what the cost could look like because it gives you estimates. So yes,
Right.
there is a small cost. Yes.
Okay, thank you.
I want to ask a follow-up question on that. Do institutions have data user agreements that they can subscribe and pay as an institution instead of individual payments?
Yes, of course. Of
Oh.
course. You can set that up with, the institution you're a part of. Yes, definitely. Definitely. And like access to ScHARe is free. I mean, all the resources we make available are, accessible for free. If you have to run your own computations, that's when you have to add your, billing project, to be able to run them. When you finish using those $300 in credits that Google provides to each user. Okay, perfect. So we're going to get started with the hands-on part. So we have our two guest experts today. One is Cindy Sheffield, whom you already know from the previous times. And even last year, she helped us immensely with another Python workshop, which was really successful. So we are really grateful that she's helping us again this year. And I'm going to let Cindy introduce herself in a minute. And I want to also introduce our second guest expert today, Sarvesh Soni from NLM as well. And I'm grateful, Sarvesh, for all your help with the notebooks for today's tutorials. And I'm going to let Cindy and Sarvesh say a few words to introduce themselves, and I'm going to let them take it from here. Thank you.
Okay, terrific. Thank you. Thank you very much, Dr. Calzoni. I really appreciate the opportunity to be here today. First of all, can you hear me okay?
Yes, perfectly.
Okay, perfect. So I am one of the biomedical librarians at the NIH Library. The NIH Library in general serves just the NIH, whereas the National Library of Medicine serves all the rest of the world. But I very much enjoy working with my colleagues here at NIMHD to bring you this information. I think it's important information. Just a quick background about me. I was with Hopkins Medicine for 25 years, where we looked at data, and the professors I worked with always said, wouldn't it be great if we could take that data and merge it together? And so 20 years later, here we are finally able to do that. And thus, even though Terra brings a few pain points in registering and using Terra, it's so extremely powerful once you get in here to be able to work with data across Anvil and all of us and share all of these projects. It's really, or repositories, it's really a powerful thing. I'm also very pleased to bring my colleague, Dr. Soni, here with me. He is a no-joke computer scientist as well. So Dr. Soni, I'll let you go ahead and introduce yourself before I move into the slides further.
Thank you, Cindy. My name is Sarvesh. I am a research fellow at the National Library of Medicine. I work with Dr. Dina Demner-Fushman, and my research interests are clinical natural language processing. Specifically, I work on question answering from electronic health records, and I have a PhD in biomedical informatics from the University of Texas Health Science Center at Houston. And I'm happy to be here and talk about Python.
Okay, terrific. Thanks. So with that, we'll just go ahead and move on to our slides. Let me go ahead and forward. Let's see. I think the slides are on your screen, correct?
I'm going to stop sharing.
Yeah. Okay.
Yeah.
And I'll go ahead and share mine. Can you see my screen okay?
Yes, thank you.
Okay, terrific. All right, so with introductions out of the way, let's just talk about what we'll be covering today. We're just going to do a very quick recap of the code or script that we used last week. So don't worry about connecting to that script this week or that file this week. You're really going to want to focus on connecting to Sarvesh's code for today. But I'm just going to run over that, look at that real quick, and talk about what we did last time. Then I'll describe the importance of data cleaning and data wrangling, and then a few key tools that you'll want to be aware of for data cleaning and data wrangling. And then I will talk about just a few points about visualization, but I'll actually leave the demonstration of that to Sarvesh for him to demonstrate when he presents his code. And then we'll just start with a machine learning primer. So you have a little bit of background knowledge about machine learning. Everyone's talking about using these AI tools, but what's really happening behind these AI tools? You want to be aware of that and know that to be able to control or to understand what bias might be infused in that, as Dr. Calzoni had mentioned earlier. So with all of that outlined, when you walk away from this session today, we hope you know about Python and Python libraries. Dr. Calzoni already mentioned a few, but we'll take a little bit of a closer look at those. Understanding the importance of data cleaning and what tools are available to you to perform that very important process, and why it's so important for your analysis. And then also visualizations, and Sarvesh is going to show you some really incredible visualizations, way more impressive than what I showed you last time. So please stay tuned for that. And then again, understanding those mechanisms of machine learning. So without further ado, let's move into that recap of part one. And you may recall from last month, I started with a basic script and we entered the data. We used an IRIS data set and JT Lung data set for two different examples. We started with some basic code. We created a script called Hello Think-a-thoners and then set two variables X and Y and allowed them to run. Very basic. Then we learned about a data structure, a tuple, and how to set those. And then we learned about a list and then use that list in a loop and looped that list around two different ways. And these, again, this code file is there for you to look at and play with at a future date. We're just doing a quick overview for today. Then one of the conditionals that we talked about is if statements, and how to use a conditional for logic, just introducing that concept. And then we played around with some basic code. Then I quickly moved you, and remember I might use that dance analogy of saying the cha-cha, forward step to the right, cha-cha-cha, backward step to the left, cha-cha-cha. And then we very quickly picked up into more advanced steps, like for instance, maybe a lady's underarm turn or fifth position or an open break, where we learned to import libraries. We had mentioned Pandas before. Pandas is a great library for analysis, and also can be used for data cleaning. And same with NumPy that is used within Python. These are very common libraries. Same with iter tools. So then we looked at this data set that I used when I was learning Python, and one of my classmates applied logic to this data set. She looked at the data types within the set, and then she very quickly parsed out different sections of the data set, just using logic and setting things to 0. And then once she had these entities or values set to 0 or 1, then she was able to run some code for some values, and then very quickly moved those into logic using if and else to parse out various aspects of that data set. Once that logic was applied and data values were grouped, like age was grouped, etc., sex was grouped, smokers versus non-smokers, glyphosate users, non-glyphosate users were parsed out in that data set. Then my colleague and classmate Joyce was able to create some really nice graphics showing these are cigarette smokers divided by gender, male versus female, and what that looked like for that particular data set. And then she was also able to demonstrate, and then these are actually divided by age groups. So she clustered the age groups together in clusters 1, 2, 3, and 4. And then she was able to do the same thing for the control group or the non-cigarette smokers. Then I quickly moved on to show you more visualizations that were possible using the iris data set. I was draw a blank on the flower and the difference between petal length and petal width and stem length and stem width. And so these are just commonly used visualizations. And then I encourage you to explore on your own and look at other visualizations. For instance, a scatter plot. Whoops, what did I just do? That was not good. I was kind of hoping to get more screen out of that. So anyway, we looked at some other visualizations. It is coming back. So here we go. And I encouraged you to play with some of the visualizations that were offered by a tutorial from Purdue using the Seaborn library that's available within Python. And again, here's a scatter plot, some bar charts. This is a nice pair plot that shows a variety of perspectives, which is often helpful in research. This one is using, a tricolor approach to those pair plots. And what I pointed out is that with really just some minor changes in code, you could produce some really powerful visualizations. And here's a pair grid. And so Sarvesh is going to be able to show you more of that good stuff. So with that review, recap from part 1, let's move on to talk about other things with Python. So we've talked about the NumPy and Pandas library, being able to use those for data cleaning, and we'll look at data cleaning in more detail. We use matplotlib, and I also mentioned Seaborn was a library used for visualizations. These are key libraries used in Python, but there are tons of libraries out there that you can use in Python. So I'm going to just come back up and go to this pypy.org page, and there are thousands. For instance, I put in intertools here. There are 584 libraries for intertools. This is that pypy.org site. It shows you that there are over 500,000 projects. There are over 6 million releases. So anything that you might want to search for or browse for, or perhaps you have some specialized thing that you want maybe the Seaborn library to do, you can just type in Seaborn and you can find a bunch of variations on Seaborn. Now, some of you might be thinking, well, what is the difference between these libraries? Does it explain exactly what one versus the other? I have to say I don't have enough experience. I'm a very new Python programmer, Python coder, I should say. I'm nowhere near the programming level, and I don't find these descriptions very descriptive. So my suggestion to you would be, if you have a certain function that you want to perform, take a look at the initial documentation, but then do your own research. That's what I have to do as I'm learning Python and I want to perform any function. And then I also ask other people who I know who are more knowledgeable than I am. So I just wanted to point out that these functions are here, and that there are all kinds of organization methods to this extensive PyPy.org repository of libraries. Just to show some of the stats of some of the most downused PyPy packages, that was my question as I was preparing for this. What are most used? And so this will this actually gave me that answer by day, week, and month. So again, Google can often offer you many answers to some of your questions. So now that we've talked about libraries for a moment, let's move on to our very first Slido question, and is terrific, right on cue. Thank you, Kevin. So if if you haven't already scanned your Slido, or Kevin, do you want to provide instructions on that?
So yeah, Mark will put in the chat right now. The link, it's the same one as before. When you pull up this Slido, you should see this question. And Cynthia, you should see the number of responses here in the top right of the right of the screen. So you just let me know when you're ready to reveal
Okay.
answers.
So, thank you, Kevin. I am not seeing that. So if they have slowed down, can you give me the most popular? There we go. Oh, I see. Now I see. Okay. Exactly. A collection of related modules that provide specific functionality. Absolutely. Thank you. Okay, let's move on to.
And you should just be able to take back screen share, Cynthia, at this point.
Okay, great. Thank you. Okay, just checking to make sure everyone can see my screen okay.
Yep, we see it just fine.
Okay, great. Thank you. All right. Okay. So which of the following examples of? Oh, okay. I might have. We'll come back to this slide. I think I put a slide in the wrong spot, but I will come back to it. So let's move on to data cleaning. So why do you want to use data cleaning? First, you want to ensure that your data is accurate, that it's consistent, and that it has good quality control to it. And this helps you with efficiency in using your data. There are several processes to data cleaning. First, you might need to parse your data. For instance, if you have first name and last name together, you might need to parse those two fields apart, or perhaps put those two fields together. Often in data, you'll find typos. People mistype things in forms, and then you end up with that typo in a data sheet. And if it's obviously a glaring error, you're going to need to fix that data. You also want to standardize that data. So for instance, if your first name is always capitalized, you want to make sure all the first names are capitalized. Same with last name. Or perhaps it's looking at social security numbers. Maybe you want social security numbers without dashes. You can probably think of several of your own examples as you fill out multiple forms, that as we all have gotten accustomed to using web forms. And then perhaps maybe you want to match IDs or duplicates because you don't want to have the same data twice. Often, as we're doing bibliometric searches, an author can be listed with maybe just their middle initial, and then maybe sometimes with their full middle name spelled out. Same thing, maybe it's their first name or last name. We need to be able to take an educated guess and consolidate those down so that we can come up with the right impact of someone's publications. And then again, consolidating things so that you have a clean presentation of the data. Conversely, if you think about data, and I'm sorry, I was displaying the wrong slide. Okay, let's move on to dirty data. And then we'll go back to some of those questions, Slido questions. For dirty data, again, conversely, you want to make sure your data is not corrupted or inaccurate or containing duplicate values, or perhaps that there's irrelevant data, that there might be data present that isn't helping you answer your question. And so you want to eliminate that data, or perhaps maybe that whole column or field in your data set if it's not going to perform or help you process the answer to your question effectively. Also, as Luca had mentioned earlier today, data has potential to bias your results. So you want to make sure that you're taking a good, clean look at the data and determine if something is going to skew the results and it's not showing up exactly the way it should to provide a clear and honest picture. Another way to ensure your data has good results is once you've figured out what that data looks like and what those data cleaning processes are for that particular data set, you want to document that. And you can also almost even automate that. And Sarvesh is going to show you ways to do that as well when we get to his code. The benefits of clean data, it allows you for informed decision making, and it's the precursor to artificial intelligence. And then also it improves satisfaction for consumers and producers. And also, especially for many of you who are likely in public health environments or perhaps maybe a regulatory environment, it helps you to maintain trust and avoid legal actions within your community. Prior to this position, I was working with the FDA Regulatory Affairs, and looking at various items. For instance, we've heard national cases of the lack of baby food, or problems with baby formula. You want to make sure that you're not on the 11 o'clock news about whatever perhaps public health product you're providing to the community. So those are some basic formats for data cleaning. I think now would be a good idea, a good time to go back to some of those Slido tools. And since I really messed up the Slido slides, Kevin, I'll let you go ahead and launch those again. Thank you. Okay, this was a Python libraries question. So go ahead and answer those. And Kevin, I'm not seeing that option to display again. Now I am. Okay. I'm not sure that it's working on my button. There we go. I think it's just going to work on yours.
Yep. Yeah, that's correct. I'll show the result.
Okay, great. Thanks. Terrific. Exactly. Very good. Yeah, R and SQL or other programming type languages, and GitHub and PyPy are repositories to find libraries. So just to clarify the answers on those. And the next question. Okay, very good. Yes, it allows for better decision making. And was there one more additional data cleaning question? And I'm not sure that we've gotten to the data wrangling slides yet. So let's hold on that one.
Great. Yeah, that was the last question there. So I will hold here and you can take back control.
Okay, great. Thank you. And I am going to, okay, can everyone see my screen okay? All right.
We're viewing the presenter view.
Okay.
Currently.
All right. That's not helpful. So let me try that. Okay. How about now?
Great.
Okay. Thank you, Kevin. Okay. So moving on to tools that can be used for data cleaning. If you're using your data in just a basic Excel spreadsheet, many of you might be familiar with the data tools on that bar. Things like filtering, using queries and connections, removing duplicates is right there within the Excel toolbar. Converting text to columns, data validation and consolidate tools are right there on your toolbar for you. If you're in, if you're working in R, then you're going to want to use a library, an R library called dplyr or tidy R, or there's also an R refine. And in Python, we talked about the pandas and the NumPy libraries. Now, what I plan to do is show you sort of what I consider an agnostic. It's not any particular programming language, but it's a tool, OpenRefine, that will allow you to clean and filter data no matter what programming language or software you're using. And it's really just for data. Here is what OpenRefine looks like. Oops. I have an intro slide for OpenRefine. So there we go. It's open source. It's a desktop application. It can be used for data cleanup and transformation. Mainly, its strengths are really faceting and clustering and reconciling your data. It will help you clean up that messy data. It is basically structured in a tabular format, and it can help you split data into more granular parts. So for instance, again, if you had that first name and last name, then you can go ahead and split that data. And it can help you enhance your data set. There are lots of tutorials for OpenRefine. So I encourage you to, here's one on library carpentry, but there are many others out there as well, but this one's very good. So I encourage you to learn more about OpenRefine. I'm going to give you a quick peek of OpenRefine. This is what it looks like when you open the application after you've gone out, downloaded it, and installed it so it appears in your browser. You simply just choose a file that you want to upload. So I have one here. This is actually the data that Sarvesh will be using in his data sheet so that you have something to compare it to. You simply download that open refined data and then click next. And then it brings that data in and you can create a project and you can just name that project and it'll show all of the data. So you have all of your data here. Notice you can show as many rows as you'd like to. I'll move this to 500 so we get a better view of that data set. Let me see if I can make this a little, yeah, I'm just going to Control X so you get a little bit of a clearer view of what that data looks like. Here we'll take this field of working class that I know Sarvesh is going to demonstrate in his presentation in a bit, but just to show how quickly and easily you can and intuitively you can facet this data, we'll just use this facet and then text facet, and it'll show me how many rows of each type of data are there. So it is intuitive and easy to use. One of the things, here's a question mark in the data, and Sarvesh is going to show you in his data set how to change the value of this to something that Python can work with. So if you were to do the same function with an OpenRefine, it would simply be it would be transpose. I messed that up. So you would come to this working class data. Then it would be edit the cells and move down to the very last column, replace, and I can type in a question mark, and then NumPy, NP stands for NumPy, and then not a number is the value that Sarvesh is going to be demonstrating in his code. And then you can see how all of that has changed in his values. Now we're moving close and moving into Sarvesh's time, and really what he has to show you is pretty incredible. So I'm going to move out of OpenRefine at this point and give you that primer on.
I have a quick question, Cynthia. Is it okay?
Sure, sure.
So unlike RStudio, where you can wrangle the data, you you have to use OpenRefine in this situation with Python.
I'm not as familiar with changing data in R. So you could use something like OpenRefine and pull that into R, and it would be easier. Yeah, I think use the tool that makes sense to you to bring your data in. It's really R's beauty is doing the analysis, not necessarily the wrangling.
So you can't just wrangle in Python. There aren't libraries for that.
There are some, and Sarvesh is going to show you in a few moments.
Oh, this is just easier and more intuitive. That's what you're saying.
Correct.
Okay.
Okay,
All right, thank you.
especially as you're learning, especially as you're learning to code.
Right.
I'm going to move over this OpenRefine question. It is used, I'll tell you the answer, it's used for data cleanup and transformation. But in the slides, here are some more books and articles as references for data cleaning that you might want to explore and we'll talk about visualization. You do want to use the data cleanup to better understand your data and prepare that data so that it tells an accurate story. And again, Sarvesh is going to show you several examples in his code of how making decisions is going to change the look of your visualization. I think it's much more meaningful to see that in code, but I wanted to point out the importance of data cleaning, the importance of understanding your data and the story that it has to tell, and then understanding any particular bias that might be in your data. So I will point that out. Then I want to move into machine learning, just a little primer about that so that Sarvesh can share his code with you. So artificial intelligence encompasses machine learning and deep learning, and both machine learning and deep learning are subsets of artificial intelligence. Machine learning is a type of artificial intelligence that can improve how software systems process and categorize that data, and the use of data algorithms it mimics human learning and gradually improving its accuracy. There are different types of machine learning. There's supervised and unsupervised learning. There's semi-supervised learning and reinforced learning. We'll take a quick look at what each of those are. So again, supervised is taught by example. It's training the data that's fed into an algorithm, and it teaches based on it teaches to categories based on preset characteristics. And algorithms can similarly sort raw data, so it can be automated. Whoops. Algorithms are good at classifying data into preset categories. They identify, for instance, identifying spam in emails or telling images apart. There are types of machine learning unsupervised there are types of machine learning unsupervised. It uses algorithms to sort unlabeled and unstructured data. Algorithms discover data patterns without human intervention, and there are good situations without clear delineations between different data categories. For example, recommendations similar to types of research projects or publications. And then there are types of machine learning, semi-supervised. It combines supervised and unsupervised machine learning to sort or identify data. Semi-supervised learning involves labeling some of data and providing some rules and structure for the algorithm to use as a starting point for sorting and identifying data. And then using a small amount of tagged data in this way can significantly improve an algorithm's accuracy. A common application of semi-supervised learning is to classify content in scanned documents, both typed and handwritten. And so generally, semi-supervised learning algorithms use features found in both structured and unstructured algorithms in order to achieve that objective. And then reinforced learning is used when an algorithm needs to make a series of decisions in a complex, uncertain environment, which is most environments. Reinforced learning algorithms are designed with a game-like rule system to reinforce or discourage certain choices within the algorithm attempting to maximize its core. When building reinforced learning algorithms, programmers set up the game's rules, but they don't provide suggestions as to where the computer should begin. The computer then uses trial and error to develop the optimal solution to the issue at hand, and reinforcement learning algorithms are used for like language processing or self-driving vehicles or game plays like Google's AlphaGo. Then there are training sets and test sets. So, for example, consider a model that predicts whether an email is spam and using a subject line, an email body, or a sender's email address as features. So what you want to do is portion your data set into training and test sets. And you can use a 20/80 split, but there are other splits as well. And after training the model, it achieves a 99% precision rate on the training set and the test set, then you expect that model to perform effectively. And we'd expect lower precision on a test set. So we take another look at the data and discover that many of the examples in the test set are duplicates of examples in the training set. Which is a no-no. You want to scrub all of the training data from the test set for whatever data that you're trying to train and then test. So with that, many of you might be familiar with that concept of when you're training a test set, recognizing the true positives and true negatives, as well as your false positive and your false negatives. And so you want to make sure that you hit the right level of sensitivity and specificity, and you might want to talk to your local statistician to make sure that you hit those numbers for whatever it is that you're trying to perform. And any statistician I know would be grateful that I put this slide in there. Then there's deep learning, which is a subset of machine learning. It teaches computers to process data similar to how the human brain processes information. but it's artificial intelligence, and it teaches computers to process data in a way that's inspired by the human brain. Deep learning models can recognize complex patterns in pictures, text, sounds, and other data to produce accurate insights and predictions. NLM is doing some really interesting work with pictures and images. It's really incredible to see what they're doing there. And then you can use deep learning methods to automate tasks that typically require human intelligence, like describing an image. I was talking to a colleague earlier, and he was saying, I never use any of those, CAPTCHA things where they make you describe an image. He said, I won't do it. So, but anyway. So natural language processing is another subset of machine learning. It's artificial intelligence technique that lets machines process and understand language like humans do, using computational linguistics combined with machine learning and deep learning and statistical modeling. And through natural language processing, computers don't understand meaning per se, but they do understand sentiment and intent. And that is frequently used in AI to make calculated results. And they learn on the job, storing information and context to strengthen future responses. Natural language processing. Here are some ways that natural language processing can be beneficial, especially for science, whether you're using data analysis or data mining. That's always been an interest of mine. Automated literature reviews. Colleagues are definitely exploring ways to do that, which significantly speeds up the process of gathering and summarizing existing research. And then there's semantic searching that we had mentioned before, enabling accurate and relevant results. Scientists can quickly find relevant articles or papers or data sets, improving the efficiency of their research. And then there's language translation. Natural language processing enables translations between different languages, breaking down language barriers and promoting collaboration among scientists from diverse backgrounds. Then there's also knowledge representation. NLP techniques can be used to help convert text into structured data, making it easier to build knowledge or graphs or ontologies. And this structured representation aids in organizing and sharing scientific knowledge. There's also, again, sentiment analysis to better understand public opinion and reaction to scientific breakthroughs or research findings. And it can be valuable for gauging the impact and reception of scientific work. There's question and answer systems, which powers allowing researchers to ask specific questions and then receive relevant answers from large data sets for scientific literature. We've done that a little bit with Slido here. And then there's automated report generation. And NLP can generate summaries or abstracts or reports automatically, reducing that manual effort needed to improve communication in scientific findings. There are clinical applications. I had mentioned the image, some of the imaging work that's going on at NLM. It helps look at electronic health records and maybe bring just those that are more emergent or unclear, to attention quicker than more routine images. So appropriate level of focus can be given to these more emergent or more unclear results. Then there's data interpretation and visualization, which again, I'm leaving to Sarvesh. So with that, I'll move on to this one last slide on natural language processing. Looking at being able to analyze electronic health records and extract important medical information, diagnosing patients, and identify patterns in medical data, and then interpret and understand complex and scientific data generated visualization there. And with that, I would like to turn the console over to Sarvesh. Sarvesh?
Okay, wonderful, Cindy. So let me go ahead and share my screen real quick. So, you can see my screen, okay?
Yes, we can.
Okay, great. All right, sure. So Cindy gave a great introduction to what we are going to demo today, and I'm going to start with very basics of how you use visualization libraries in Python to visualize basic numbers. And this most of it, if you attended the last session, you might have looked at, but it will be a good refresher. So Cindy talked about matplotlib. So matplotlib is a library for plotting graphs in Python, and NumPy is another package which is used to work with numbers, basically. So you can work with so there's huge data sets containing numbers, and NumPy makes it a lot easier for computing on those numbers. So it's a good library to have a hands-on. And
sorry for interrupting you.
sure,
Let's
yeah.
make sure that everyone has access to the notebook you're.
Oh, sure, yeah.
So
of course, yeah.
I'm
So
going to paste the link in
sure,
the
yeah.
chat so that everyone. Okay, so if you can copy and paste the address that I just pasted in the chat in your browser, you're going to access a page. Sarvesh, okay, no, I can do that. You're going to access a page where you're going to have a list of notebooks. Okay, perfect. And scroll to the end. There are going to be multiple copies. Access the one that matches the initial letter of your last name. I'm actually going to share my screen for a moment, Sarvesh, if you don't mind.
Sure, go ahead.
I'd like to show everyone what they need to do.
Of course.
Okay, so the link that I pasted in the chat brings you to this page on Terra. So it's a list of notebooks. You're going to have to find this one, ScHARe Thinkathon September. And you see that we created multiple copies. So depending on how your last name starts, if it starts with a letter from A to D, click on this one, E to H, this one, etc. So pick the one that corresponds to your last name. And I pick one at random. You have to click on open or playground mode, as I explained at the beginning. Okay. So you click on open like this. Okay, perfect. Sarvesh, you can go on, I guess. Thank you.
Sure, thank you. Thank you, Luca.
And if you need help, just let me know. I'll help you.
I hope most of you are able to open the notebook. So you can follow along and I guess ask questions in between. It's okay to interrupt. All good, okay.
Perfect.
Okay, so I'm gonna go slowly so that if people are still opening it up. And so I talked about that we're gonna use these two packages for initial exploration. And in this very first cell, what we are doing is we are using the NumPy package to create a list of numbers to plot on a graph. So there's a function called linspace provided by NumPy library, and what it does, it creates equidistant numbers between the provided range. So when you say linspace of 0 to 20, it will create a default of 50 numbers that are equidistant between the range of 0 to 20. So when you try and run this other cell, you can see it created a total of 50 values. As you can also run x.size and see that there are a total of 50 values, and then all these numbers are equidistant. And why we did that was because we want to plot it on a graph. So if you have these different numbers, you can plot it against another set of values. So we use another function provided by the PLT module from matplotlib package. So matplotlib has a pyplot module which we imported, and we use that use a function called as plot provided by the PLT module that takes in two parameters here. So first parameter is your x values. So what x values do you want to plot on the graph? And then the values on the y-axis that you want to plot on the graph. So on the x-axis, we want to plot x, and on the y-axis, we are plotting 5 plus x. So essentially what we are trying to plot here is the line that that can be represented by an equation y equals 5 plus x, right? And then we, just for a reference, we plot another line, which is y equals 1 plus 2x. And as you can imagine, you pass 1 plus 2 multiplied by x in the y portion of this function. You can decide how you want to plot this line using matplotlib. So in this case, we are plotting the second line using dashed lines. And then you finally do plt.show to show this graph. So when you run this particular, you will be able to reproduce this image. And you can see that the dashed line is y equals x plus 5, while the dashed line is y equals 1 plus 2x. You can also add labels to the graph. So this is essentially the same graph, but you do. I've done these two additional things now, where I added the labels to x and y axes to make the graph more informative. So and the x-axis shows, for example, the years of experience, and then the y-axis shows the average salary in terms of $1,000, for example. Right, so there's all these things are possible, which are basic things in matplotlib. And then you can save these images directly using Python. And the way to do is that you can take the reference of current figure from the PLT module. So you do .gcf, which gets the current figures object, and then you can use the get current figures object to save that image. You provide the name of the file that you want to save to, and these are some of the options that you can use to decide how you want to save the image, whether you want the white spaces around it or not, and so on. So when you run this, it saves this image in the directory where your Python notebook resides. So in this case, it's in your it's in the same directory from where you're running this code. So I can show you on my side. So this is the directory that has this notebook, and this is the image that we just saved, test.jpg. And you can open and see that this is the image that we saved, which you can use to share with others and so on.
Can I ask a quick question?
Mm-hmm.
I've made this mistake. I taught myself Python out of desperation and necessity last year, being really frustrated with Excel. And I found myself making my own like graphs and everything for a poster very, very slowly and painfully. And in doing so, basically, I didn't save my code, and then obviously had to make edits and, tried to reverse engineer my images. And basically, like, you know what I'm saying? Like, you can't go from like a saved image PNG file back to, right? You're just basically start all over again, right?
That's correct. Yes.
Yeah.
So yeah, it's yeah. So image is basically the output of the program that you wrote, and that output is oftentimes just static image.
Yeah.
This basically will be hard to figure out unless you have metadata associated with the image. In this case, it's not. So
that's what I thought. I just want to make sure. Yeah. Okay.
Yeah, so it's a good opportunity to say that, yeah, you can. So if you're running something called as a Jupyter server on your local system or even on cloud, most of the times it automatically saves the file, but you can also save the file yourself. So I think there's a option to save it. Yeah, so save and checkpoint. So you have it in most of the Jupyter instances where it will save it for you automatically, or you can save it yourself. So that way you don't lose your work. But yeah,
Lesson
that
learned.
is a very, yeah, yeah. And that is a very common problem. I still experience it. So I think that is fine. So yeah, regular backup is the key. So moving on, so we saw an example of how you can plot a line. So when we plotted all these, so if you remember at the beginning, we created a set of 50 points and we plotted those 50 points, but you are seeing here, what you're seeing here is a line, because the plot function, what it does is it connects those points. So what you see here is a straight line instead. You can also plot those points specifically, and you can do that using a function called as scatter. So you can create a scatter plot, which plots all those unique points separately. So in this case, we are plotting the line y equals x plus 5, but instead of connecting all those points, we can just plot all those points separately, and you can see how it looks like. It's not just limited to lines. You can, whatever you pass essentially to these two arguments in the scatter function, it will plot it for you. So for example, if you pass x on the x-axis and you pass x multiplied by x plus 5 on the y-axis, then you are essentially plotting a curve with equation y equals x squared plus 5. And you can see that how it looks like between 0 and 20. Between the values of x ranging from 0 and 20. Right. So moving on, I want to talk about just one more thing before we move to the fun stuff with the data set that we are going to talk about. Figures and subplots. So Matplotlib also provides functionality for you to combine different types of plots in the same figure. And how it does it is through a function called as figure. So it provides you with a kind of figure or a container in which you can add different kinds of graphs. So we create a figure using this function, and then in this figure, we can add different plots, and we can define where do we want to put these separate figures, different subplots in the entire figure. So all these three values, what it's saying is that 3,2 is the matrix in which you want to put your subplots. So as you can see, there are 3 rows here and there are 2 columns. And then you say that I want the first subplot to be at the location 1. And you want the second plot to be at the location 3. So 1, 2, 3, this is your third plot. And then you want the third plot on the location 6. So 1, 2, 3, 4, 5, 6. So your 6th location, you have the third plot. And then you can separately plot different types of graphs on all these different subplots. So you can see that on subplot 1, we plotted a line. On subplot 2, we plotted a scatter plot. And on subplot 3, we plotted a histogram, right? And histogram is similar to how you plot a plot or scatter, but with a different arguments, which we are going to see again later in the slides, later in the notebook. But this is a very basic example of how you can also combine different kinds of graphs. So there's another library called as Seaborn, which is built on top of Matplotlib, but it provides more high-level interface and provides more, in simple terms, it provides more color palettes. It can help you easily create attractive figures and more informative graphs. So you import it the same way in Python, and as is just a way to basically abbreviate some of the packages. So when you import Seaborn, you don't have to write Seaborn all the time. You can import it as SNS. So in this way, you can use it as SNS going forward in the notebook. So in this case, we are using SNS.barplot, and what it's doing is using the barplot function provided by the package Seaborn to plot a bar plot. And then you pass your data into the function. In this case, we are passing a matrix of 50 cross 3 size, and it's plotting all those 50 numbers on all these three bars separately. So let's get to some good stuff where we also try to drive meaning from these visualizations and see how in practice you can use these visualizations to make sense of a data set, right? So everything essentially starts with a question, right? So let's say you have a question of like, how well can we determine whether a person makes $50,000 a year based on census data? So let's say you have access to some census data and you want to determine the salary of an individual based on certain characteristics that you have available for that data set for that person. So the first question that comes is like, what kind of data set do you have? So the data set that we are using is an adult census income data set that comes from UCI repository, and it is also available at Kaggle. So UCI repository is a repository of it's a collection of data sets that's maintained by the University of California, Irvine, and there are many other kinds of data sets that are frequently used for machine learning and data science. And Kaggle is a platform for that hosts data sets as well as code notebooks like the one that I'm presenting today that contains sample examples and resources for data scientists to come together and collaborate and look at each other's codes and learn through that process. So I really recommend checking those resources out if you're interested in looking into it further. So the data set I have downloaded from Kaggle. It's available to you in the directory with name adultincomedata.csv. And it is a CSV file, so it's a comma separated value file. It contains the data set separated by commas. The first line provides a header, and all the different lines after that contains the data. It's in the tabular format. So the CSV, one of the most popular libraries to load a data set in the CSV format is pandas. So we are going to use pandas for our purposes. So we import pandas library using the same import mechanism in Python. And pandas package is used to load all different kinds of data sets, including CSV. You can even load Excel into pandas. And how it loads the data sets into Python is via a data frame. So when you load a data set, and so for example, in this case, we are loading a CSV file. So you use a function called as read CSV provided by the pandas package, and you pass the name of the file that you want to load. And it loads this data set into an object, Python object called as data frame. So you can provide any name to it, but most frequently you will see that it's just called df for brevity, but you can call it anything. You can call it data, you can give a more meaningful name according to your own project. So here we loaded this data set into an object called df, which is a data frame. Pandas provide a function called head, which can help you quickly peek at the data set. So what head does it prints the first 5 rows from the data. So as you can see, it interpreted the columns perfectly. So you see there are multiple columns here. And for those columns, you have values. So it is age, So this individual has a range of 90, is a high school graduate, widowed, and then the race, sex, the hours per week, and native country, and then the final variable is income. So let's try to analyze this data set a little bit more and try to know the data before you perform any analysis. That's the process of when you use a data set. You try to make sense of it first, and then you see if you need to clean it somehow before running the model. So those are the three things that we're going to do today. So we're going to explore the data through something called as exploratory data analysis. It comes under that umbrella. Then we're going to clean it a little bit by imputing the missing values. And then we're going to build some models and see how you can improve the models using one of the examples. So you can check the shape of a data frame using this using shape provided by data frame, and you can see there are more than 32,000 rows in the data set with 15 columns. So you have 15 different values. Out of these 15 values, the 14 variables we can use as input features or the input variables, and then the last variable is for your output. So we want to predict whether the income is less than equal to $50,000 or greater than $50,000. So that's our task, that we want to identify if this last column is less than equal to 50,000 or greater than 50,000. Let's first try to see how the final value looks like. So you can do that by, you can access the column by providing a column name inside square brackets. So when you say a df of income, it will help you access the column named income. And then you can do value counts to print the values of the counts of the distinct values available for that column. So in this case, you can see that there are more than 24,000 rows with the value less than equal to $50,000, and there are more than around 7,800 rows with individuals who earn more than $50,000, for example, right? So that's our data, that there are more people who earn less than $50,000 than there are who earn more than $50,000. And throughout the notebook, whenever you see right after the output something in the bullet points, that's some of my observations for you to start thinking about, like what we did and what did we observe from this output. So that's what we do usually, that we create if we plot something, we try to analyze, and we're trying to make sense of the data. So there are two types of variables broadly that you will encounter. So one are numerical variables. So in the data set, you can see that there is age, there is education number, there is capital gains, capital loss, and hours per week. So all these can be considered as numerical variables because these can be measured. You can measure those, like what are the hours per week. You can use it in mathematical calculations, for example. So in order to visualize those, you can use describe function from pandas, and it can print some basic statistics on these numerical variables. So as you can see, the age, the mean age is in the data set is 38.6 years. The standard deviation is 33.6 years. And you can see that the individuals, so the people have worked on an average 40 years with a standard deviation of 12 years and so on. So there are another types of variables which are categorical variables. So these are the variables which are more discrete. You do not count it, but they represent categories in your data. So for example, working class, education, your marital status, for example. So marital status we saw above it was one of the status was widowed. Here the topmost occurring marital status is married. So these are different categories. So you cannot really count it, but it's just a different type of data that can be present. And you can also see some statistics like the number of values, the unique values in the data set by including the object type of data sets and data in your data frame. So when you do this, you can see the categorical variables. So you can see there are, for example, 15 distinct occupations present in the data set. And we can also see that most people are have a native country, United States, in the data set. But note that the unique values that you see here may have some missing values in it. So I think if you noticed when we printed the first 5 lines, there are some question marks in here, right? So the question, what do these mean? So they mean for this data set that they don't know the value of this particular column for this particular individual. So for this individual, they don't know what the occupation was. So this counts as missing values, and we'll talk about it later. But that's also counted in these unique values. You can break a subset of data from your whole data frame and for analysis on like a smaller subset of your data. So that's what we are going to do. So let's look at some smaller set of values from age, education, occupation, and native country. So you can do this by passing all those different columns that you want to look at as in a list to the data frame, and it will return a modified data frame with only those columns. So when you run this, you can see that there's only 4 columns in this subset of data frame. It doesn't matter too much, but there's a way to just do it, and then you have like a smaller data set to play with in your notebook. Let's try to understand the distribution of age in the data set a little bit more, right? So you can do that by easily plotting a histogram. So you can do that by accessing the age column again, using the same way as before, and using a histogram function provided by pandas itself. So you can use pandas itself to plot your data, which is cool. And it underlying pandas, it uses matplotlib to do all these plotting, but you don't have to take the data out from data frame and then pass it to matplotlib functions to do that. You can do it directly with your data frame, which is awesome. So you can use this series, you can access this column and then just use the histogram function and just provide how many bins you want to use, and then it plots the histogram for you. So what do you see from the histogram? You see that most people are in the age range of 20 to 50 years of age in the data set, and it's a more like a right skewed distribution where you see a little bit longer tail going to all the way to 90 years. You can also visualize how the unique values for a particular column. So for example, you can see the unique values that are available in the native country. So in there, you can see that there's United States, there's Mexico, Greece, and so on. And then you also see there's question mark in the native country. So what this means is that there are values which are represented as question mark in the data set for native country. And these account for missing values. So we'll take care of it going forward. There are more complex graphs that you can build very easily, but with just like a few lines of code in Python. So you can, for example, build a box plot and analyze the distribution of age across the different native countries of the individuals. So you can do that with the box plot function, and you can say that on the column, you want to plot the values of age, and you want to divide it by the native country, and you can provide how big the plot you want to see. And this is just to make your plot look pretty. You can decide what the font size you want the labels to be and so on. And you can see in the plot now that there is the distribution of age is varying across the countries. It's not the same. Hungary has the highest median age, as you can see here. The median age is among the highest among all the native countries. The Guatemala has the lowest median age in the data set. United States has the most number of outliers in the data sets, as represented here. And as you can see, the most spreaded data is for Hungary, which goes from all the way from 30 to 60. You can also visualize how the age varies across different occupations by quickly calculating the basic statistical basic descriptive statistics for age across occupations. And how you do it is by the group by functionality from pandas. So you can say group by, and whatever column name that you provide in the group by, it groups your data by that column. So in this case, you're grouping your data by different occupations. And then for that, for those groups, you say describe to calculate descriptive statistics across all the columns or all the remaining columns. And then you can access what column you want to use to further analyze the statistics for. So in this case, we are analyzing the occupation statistics for age. So when you run this, you can see that there's, for example, the armed forces, there are a total of only 9 values. So there's a few number of rows available for this category, and the mean age is 30 years, for example. And you can see that the mean age for professor specialty is 40.5 and so on. You can plot the age. You can plot the age for different occupations. So it's a little bit difficult to visualize the different ages here. So it's always easier if you can plot your data, and that's where these visualizations come into picture a little bit more. You can plot, in this case, a bar plot with the mean and median age for each occupation. So you can see that the transport moving has a median age of somewhere around 38, and at the mean age somewhere around 40. And from this figure, you can see that for the armed forces and for the handlers, cleaners, the mean and median age ranges are more on the lower side, and while the ages are on the comparable range for the others. You can plot other types of plot as well. For example, you can analyze the distribution of different types of occupation using a pie chart. So you can plot a pie chart using using the pie method provided by pandas itself. So from the data frame, you can go to plot, and then you can access the pie function, and you can provide the data set. You can provide the column that you want to use to populate your pie chart. In this case, we want to populate with count, so it will just show you the proportion of different occupations in the data set. And it'll give you some idea that, okay, the occupations are not uniform in the data set, for example. But you can see that this chart is static, right? You cannot really interact with it. So there's another type of library in Python called as Plotly, which is used to build interactive plots. And it's built on top of JavaScript library, which helps you interact with your graphs and get to know a little bit more about your plots when you're plotting them. So unfortunately, that rendering is not available for this platform. So if you, for example, is running this exact notebook on Colab, which you can go ahead and upload this notebook on Google Colab. The free version of Colab is just fine. And on that, if you just uncomment this particular line and run it, it will create a graph with which you can interact. So when you run this, it will, instead of printing a PNG image. So as of now, what it's outputting is a static image again. But since Terra does not support it, you can use the other formats. But what we can do to visualize the interactive graph is you can save it using the Plotly itself. So in this case, we plotted the pie chart using this pie function provided by Plotly. And we passed the data, and you can provide what values you want to plot. In this case, we are plotting the count values, and then you can say what names to write in terms of labels, and then you can provide the title. And we stored the reference of this figure, and we can use this reference to write this image. And we can write the PNG image, or we can also write it as an HTML file. And the beauty of writing it as an HTML file is that when you write it as HTML, you can use the interactive features. So when you run this, it saves the occupation. And as you can see, now you can interact with the graph, right? So you can see that there's 12.6%, but the total number of craft repair individuals are 4099, for example, right? So that's cool. But if you run it on other platforms, like for example, Google Colab, and change this particular line, you can see that interactive graph right here in the notebook. So yeah, that's possible. But there's also has a learning opportunity that your code may not work exactly the same way across different platforms. So that's something to keep in mind when you're building your projects with Python. Then there are advanced visualizations where you can build more complex graphs using Python and Plotly. So you can build graphs where you can include a dynamic nature to it. For example, you can build a graph where you can dynamically decide what value to view automatically. I will not go over it too much in the interest of time, because I think it will be important to look at the missing values example a little bit, but feel free to play with it. And there's a way to save it as HTML so that you can interact with you can experience the interactive nature of these plots as well, right? So you can go through it, and also the other kind of plot, which is a stack bar plot. And okay, so this is interesting. So in the data set, you saw that there's a column called as education, and there's a column called as education.num, right? So the education column gives you the education values, while the education number gives you a bunch of numbers. What happened when we tried to plot a cross tabulation of these two variables? So in simple terms, we are plotting the frequency of the corresponding values between these two different columns. So for example, what this table is showing you is that when the value is preschool and the education number is 1, how many such values are there? So this graph tells you that the education number is nothing but just another representation of education, because for all the values that has, for example, high school graduation has education number 9 associated to it. So essentially you can use either one of these variables to have the same information. So this is an example of duplication in the data set, and it also comes under cleaning, that you can remove this one particular column without actually losing information from your data. right? So we will do that when we go forward. We will remove this column before building our model, so that we are not dealing with duplicated data, and we are not increasing the amount of input variables that do not add information to our model. Let's try to look at the missing values. So Cindy talked about the missing values and why it's important to mitigate those issues. So let's remind ourselves that there were a total of 32,000 rows in the data set. And there's a function called as info in pandas that gives you the details of how many non-null values are present in the data set. Here you can see all the values are non-null, right? But that doesn't mean that it's a perfect data set, because as we saw earlier, values were represented by a string question mark. So pandas will interpret it as a value. So it will not tell you that it's a null value or a missing value. So there's another better way to check for null value, which is null. And you can do sum. So it will give you the counts of null values across your variables. So you can see all the null values, the count is 0 as of now, but it is because it's all represented by a string question mark. So what happens if you replace those values that are question mark across your data frame with an actual null value? So the null value, one of the ways to represent a null value is by NaN, or not a number, provided by NumPy. So when you do this, you can see that now when you do df.info, some of the columns do not have the total number of non-null values have now decreased, right? And it may be difficult to analyze using this function, but this function tells you a better way to view the missing values. And when you do this, you can see that work class has more than 1,800 missing values, and similarly occupation and native country has missing values, right? And why are there missing values? There may be multiple reasons. There are human errors, there are technical issues, there are sometimes privacy concerns because of which they remove specific values from the data set. And sometimes there is just inherent nature of the data to have missing values, because that's how the data collection is performed for that particular observation, for example. So we want to get rid of the missing values because of several reasons, and some of which Cindy mentioned in her slides. But it also it helps in better analysis, and some of the machine learning algorithms that do expect like the data set without any missing values. So there are different ways where you can handle the missing values. One of the ways is a common approach that you might think of, that just get rid of the rows that has these missing values, but it can reduce your sample size, right? So as you can see, like you can lose 1,800 rows for work class, and then if these are different rows, then you can lose a lot of your data. Another way is imputing the values, and imputation means that you try to replace the value, the missing value, with something else. So you can replace the missing value with the mean value across that column, or the median value across that column, and so on. So in this case, in our case, we are trying to, we will replace all the null values with the mode or the median value of that, the mode of that particular column. So mode is like the highest occurring value across the column, right? So when you do df dot, so you can do it very easily in pandas. You can do that using data frame, and then use the column name, and then use fill NA, which will fill all the null values with whatever value you provide here. And we provide here with the mode value, and then in place equals to just changes the data frame then and there. You don't need to reassign data frame to data frame now. And then we do this for all the column names which has missing values. So it's work class, occupation, and your native country, right? And then you can check it again and you can see like the data set does not have missing values. So it's good. Great. So let's move to the last part, which is machine learning, the fun stuff. So for machine learning, how I think Cindy gave a great overview of how we go about building models and the training and the testing data sets. So the convention is that you have some input variables and then you have an output variable. So in our case, you have these input variables, which is everything other than income. And we are also removing education num because we saw that education num is nothing but education. And then your output variable is your income column, which is your greater than equal to 50 or less than equal to 50 or greater than 50. So your input variables are these 13 variables now, and then your output variable is this is one output variable. We split it into training and testing. So this helps us get a better estimate of our model on unseen data, because when you build your model on, for example, your training set, you keep your testing set aside. You do not use the testing set when you are building your model. And then when you are satisfied with your model, you see the performance of your model on your test set, which is essentially unseen to your model. So there's a way to split your data using a function called train test split provided by a library called sklearn, right? So sklearn is one of the most popular machine learning library in Python, and it provides various modules and functions that you can use to perform a lot of frequently performed operations in machine learning. So in this case, one of the operations is splitting your data, right? So it provides an easier way to just import this function, and then you can use this function to pass your data sets, your X and Y, your input and output, and then you can say what is the size of your test set. In our case, we are splitting the data into 80% training and 20% testing. So we can provide that the test size is 0.2 or 20% of the data set, and random state is just a way to tell like is a way to reproduce your results better. So whatever random state you provide, if you come again and run this exact same code with the exact same random state, it will produce the same split, however random it is. So that's there. And then we oftentimes, before running the machine learning models, so you have these inputs split into training and testing. That's good, right? But the models only work with numeric data. The machine learning models usually only expects numeric data. So what about the categorical data? So categorical data was present in the form of strings, right? So work class, the education, right? The 10th grade and high school graduate and so on. So we want to convert all those to numbers. So basically, we want to assign high school graduation to a particular number and then convert all those high school graduate instances in the dataset to that particular number. And there's an easier way to do it, again, provided by sklearn through a pre-processing module. So you can use pre-processing module, and there's a function called as label encoder. And label encoder can be used to transform your data into numerical features. So when you try to visualize your transformed data frame, now you can see that all the features are now converted to some value, some numbers, right? So sex was, if it is male or female, it assigned a set number to it. So for example, if it assigned female to 1 and male to 0, it transformed all those instances in the data set with the corresponding number. So you don't have to worry about that. But still, the values that you see here are on different scales, right? And when you're working with machine learning models, it's always a good idea to have all your values on the same scale, so that some of the features that has higher values are not biasing the model toward one direction more, right? So for example, age is 41 and race only has, for example, 5 or 6 distinct values, right? So we don't want age to play a major role just because it contains higher numerical value, for example. So before feeding our data to the machine learning model, we want to change the scale of all these numbers to the same scale, and the process is usually referred to as normalization. And what we do is that we standardize all the values to a normal distribution. And we essentially calculate the mean for each column. We reduce the mean from each value and then divide it by their standard deviation. So as you might have figured from the formula, it converts your data into a normally distributed data for each column. So when you try to print your data after this transformation, you can see that the values are now normally distributed. And it's again, you don't have to worry about these calculations, the nitty-gritty details of these calculations, because sklearn provides a method called as standard scaler that can help you do this pretty easily, the standard scaler class. And the final step is now running the models, right? So that's again, sklearn provides a class for logistic regression, which is one of the machine learning models. And you can fit your training data to the model, and then you can run your model on the test set to get your final predictions. And you can use the accuracy function provided by sklearn to calculate how well your model performed. So in this case, you can see it performed with 80.29% accuracy using logistic regression. And similarly, the perceptron model was built almost following the same steps, but using a little bit different, the different class for perceptron and some different attributes for that particular class. And it performed with 73.71 accuracy. And very finally, I think there's a method of choosing your features, so which is called as principal component analysis. It is a way to it is one of the mechanisms to determine which of the variables in your dataset can be used better for building your machine learning models. So when you do PCA and you try to get the variance ratio, what it's showing you is that which of these variables is responsible for what percentage of variation in the data set. So as you can see that the last two values are responsible for only 5 and about 3% of variance in the data set. So what happens if you remove those columns before building your machine learning model, right? So in this case, we have to remove income because it's the output variable. But if we remove the hours per week and native country column, which are the last two columns, and we build the model again, it's not performing a little bit better because you have less input but more quality input. So the model is now working with better accuracy. And then there are more ways to clean your input. That comes like the whole chapter on feature engineering. You can transform your features to make your model a little bit better. So sorry, I could not go into like too much detail of how these analysis were performed, but I hope the notebook is commented well, so you should be able to make sense of the different steps that were performed in order to build these models and get these results. But I hope you learn the gist of building the models and how you can select these variables for building your model. And so that's the end of it. So happy to take any questions if we have time for. Thank you for listening.
Thank you, Sarvesh. Just the code is incredible, and being able to see how your visualizations become interactive in that HTML environment, I think, is extremely powerful to see that. Hopefully, what we've presented together today, I tried to provide a high-level overview to tee you up for all of the great stuff that Sarvesh shared with you. So again, we'll take questions. And in general, and to answer the cost, so it is free to you today. If you want to use it after today, you'll have to create an account, and in that account, you'll get a $300 credit, which burns rather slowly. So you would be able to use it without cost to you for quite a while. And I see that Luca posted that response.
Yes. Yes, and the slides from today will be posted on the page that I just provided the link for in the chat. And again, the notebook we use today will remain available to you in the ScHARe workspace, independently of access to computations and free billing. Perfect. So are there any more questions? Okay, let me see. So Terra is the only cloud-based we can use for all of us on Azure. No, you can actually use Azure as well. It's been added recently. I mean, the Terra platform, of course. You can actually use an Azure account to access, but you have to use Terra. Any further questions? Okay, perfect. So I would like to thank Cindy and Sarvesh so much. Your help was precious. Really, you did a great job. And thank you for your enthusiasm, your dedication. So Kevin, thank you so much. So if you can launch the evaluation poll that we always do at the end. So please evaluate this session. It will help us improve, and it will inform like the future events. And thank you so much for attending and for joining us today. The link to the poll will remain open for a while. So we're going to wait before we close the call. It's going to be available for a few minutes. Thank you so much again for joining us. Thank you, Cindy. Thank you, Sarvesh. And thanks everyone for your
Thank you, Luca.
participation.
Always my pleasure. Thanks. Bye-bye.
Thank you.
Thank you all so much. This was awesome.
Yeah, Calzoni, if you don't mind, can you give the link of the notebook we used just now?
Yes, yes.
I'd appreciate this. It was very helpful.
I'm glad. I'm going to provide the link in.
Yes, thank you.
Sure. Great. I just pasted the link in the chat.
Yeah, I just saw that. Thank you very much.
You're very welcome. And again, we are going to upload a copy of this notebook onto our ScHARe workspace. So it's going to be available to you indefinitely.
Okay.
All right, thank you, everyone. Luca, I'll end the Zoom call, but the poll will remain up even after we end the Zoom.
Perfect. Thank you so much, Kevin. Thank you all. See you next time in October for our Thinkathon on the repository. Thank you. Bye-bye.